I'm going to tape a video now on coordinate proofs. So in class we went through and determined like what we had to show or to prove algebraically to determine that a figure was a certain polygon. So
the following teachers, please report to the front office conference room.
The first thing that you need to know is your slope formula.
And Ms. Fowler. Please report to the front office conference room.
The slope formula is just the change of y over the change of x. And then the distance formula is the distance formula that's found on your formula sheet. And you're going to use those two. So to prove a figure is a trapezoid, the one thing that we're going to have to prove is that we have one pair of opposite sides that are parallel. And as you know, to prove that sides are parallel, I need slope. So to prove sides are parallel, you need slope. Find M. And if they're parallel, the slopes are going to be congruent to each other. So hopefully that will help you do that. And then to prove that it's a parallelogram, I have two pairs of opposite sides that are parallel. So in this case, I have that side that's parallel. So when I'm proving this, I actually have to go through and have to prove that this side has the same slope as that side, and this side has the same slope as that side. So up here, we just had one side. And also, when you do that, you can also see that the opposite sides are congruent, but that doesn't prove that it's a parallelogram. And that the diagonals bisect. Actually, it does prove that it's a parallelogram, but if it's a parallelogram, the word parallel should trigger you to find the slope. And then we have kite, and I have two pairs of consecutive sides that are congruent, and it's indicated by the tick marks. So I would use the distance formula to find length and then compare. And I would have to find the distance of all four sides here, because I would have to say that one side's congruent to the other and then another side is congruent to another side. The next one is a rhombus, and here all four sides are congruent, so to prove that I'm going to have to use the distance formula. So that's why I went over the distance formula up there. Because you use the distance formula to find the length of sides to prove congruency. To prove that this is a rectangle, I need to know that opposite sides are parallel, opposite sides are congruent, but the one thing that stands out, so if they're parallel and if they're congruent, and I have consecutive sides that are right angles, not right triangles, then it is a parallelogram. So that kind of indicates parallel, congruency, and then that they're all right angles. Square, I have to prove that all sides are congruent, so I'm going to need to use the distance formula. Anytime I'm proving sides are congruent, distance formula. Opposite sides are parallel, so I need to find slope, and consecutive sides are parallel. So perpendicular, so I need to find my slope. Remember, and we'll go over this, I'll put the cheat sheet that we had today in class up, so you can have you can write that down or pause it to take a picture in a second. Then we have an equilateral triangle, and an equilateral triangle, we know that all three sides are equal of that triangle. We also know that all angles are congruent 60 degrees, but we will be proving that by using the distance formula. Okay, and this is one tick mark. Isosceles triangle or isosceles trapezoid, it will be where two sides are congruent. And also by knowing that, you know by the base angle theorem that we have the angles that are opposite. Those two congruent sides are also congruent. And then over on the next page, we talked about the midpoint and how we prove that a point is a midpoint. And we just proved that the two segments, it breaks it up into are congruent to each other. So you use the distance formula. Segment bisector, same issue. I proved that these two segments are congruent to each other. And then to prove that a point is on the circle, I just plug the point value or the x, y of the point coordinates into the formula, and it should be equal to r squared. So I'm going to pick a couple or one or two to do here. I'm going to pick proving that the quadrilateral is a square, which is number 4. So if I prove that the quadrilateral is a square, I have to prove two things. The first one is all four sides are equal, or all four sides are congruent to each other. If I only prove that one, though, it could also be a rhombus. So I also have to prove that all four angles are right angles, or equal to 90 degrees. So consecutive sides are perpendicular. So the first thing I'm going to do, because it's kind of the easiest thing to do, is I'm going to plot it first. And that's 2, 2, so that's A. And then 5, negative 2, that's B. And then C is going to be 9, 1, C. And then D is going to be 6, and then I go up 5. And I know that this is not exactly perfect, and it's not going to be perfect, but we'll use our coordinates and not worry about how bad my graph is. So the first thing I'm going to do is I'm going to find the slope. I'm going to find the slope of AB, I'm going to find the slope of BC, and I'm going to find the slope of CD and DA. So the slope of AB, and that formula is y2 minus y1 over x2 minus x1. And I'm going to choose B to be my x2, y2. So I have negative 2 minus 2 over 5 minus 2. So that's going to be negative 4 over 3. So my slope of AB is going to be negative 4/3. My next one is I'm going to find the slope of BC. And I'm going to use my C as my x2, y2. So it's 1 minus negative 2 and then 9 minus 5. So 1 minus negative 2 is 3. 9 minus 5 is 4. So far it's looking pretty good, because negative 4/3, its reciprocal is 3/4. Negative reciprocal is 3/4. And then the slope of CD is going to be 5 minus 1 is 4. And then 6 minus 9 is negative 3. So again, we have negative 4/3. So these two sides are actually going to be parallel, which they should be in a square. And then the last one is DA. So I'm going to take 5 minus 2 is 3. And 6 minus 2 is 6 minus 2 is 4. And so the slope is up here is going to be 3/4. And so that proves that I do have 4 right angles. And so the next thing I need to prove is that the length of all of these sides are congruent to each other. And to do the length, to prove congruency, I have to use the distance formula. And when I do that, I just plug in x2 minus x1 squared plus y2 minus y1 squared, and that's going to equal the square root of 25, which is going to equal 5. And as you are doing this, you will find that every one of the sides is equal to, but you have to work it out, but for time's sake and for the sake of a long video, here I'm going to leave it out, but you can write the distance formula or use the Pythagorean theorem to solve for the hypotenuse. Okay. So the next one I'm going to look at is I'm going to prove that triangle ABC is similar to triangles DEF. So the first thing, by side, side, side. So the first thing I need to know is by side, 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 that means that the corresponding sides are proportional. So what that means is AB is corresponds to DE, and that's proportional to BC over EF, and that's proportional to AC over DF. So to prove that, I have to find the length of all of these sides to make sure that they all equal that fraction. So upon doing that, and you can plug it into your distance formula, I find that the distance of AB is equal to the square root of 20, and the distance of DE is equal to the square root of 5, and I'll show you the work in just a second. And the distance of BC is going to equal square root of 32, and the distance of EF is going to equal the square root of 8, and the distance of CA is going to equal 6, and the distance of FD is going to equal 3. And here's all the work. I just plugged it into the distance formula, so you can do that on your own. And so now I'm going to plug in these lengths. And when I do, I'm going to go ahead, I'm going to put AB over DE. And that's going to end up being the square root of 20 over the square root of 5, which is going to end up being 2 when you put it into the calculator. The square root of 32, because I'm doing the length of BC over the length of EF over the square root of 8, is going to equal 2 also. And then I have 6 divided by 3, that's going to equal 2 also. So that's a little bit about the coordinate proofs. So you have to do the distance, you have to use the slope formula, and every now and then you'll use the midpoint formula. So this is kind of the formula sheet that you need to be familiar with, and you need to have all of these things memorized, everything but the distance formula. But you need to know to find the midpoint, you add the 2x's divided by 2, add the 2y's divided by 2. To determine if two lines are perpendicular or form a right angle, you have to find their slopes of all of them and see if the consecutive sides are the negative reciprocal. To prove that they're parallel, the slopes have to be equal to each other, so you have to find the slopes. And here's the slope formula, and then the distance formula. The distance formula is the only formula that is on your formula sheet, so make sure you know these two.